creating waves in the ripple tank. Okay, and you can see the waves. Okay, I'll do it from down here. Right, so you can see the waves. I'm actually creating crests and troughs by doing this. I can create periodic waves, or one wave at a time, one wave pulse. Okay, and the goal here is to study the behavior of waves in 2 dimensions. So let's first point out some features that waves have that we can see on the screen. Let me get to that. First property we want to look at is reflection. So if I put a boundary in there, so I'm just going to put a block of wood in here, parallel to the wavefront. So that block of wood is going to go parallel to the wavefronts. Parallel there. Okay, and so let's just look at one wavefront. It hits, and then the reflected wave bounces right back, right? So it goes right back. Okay. So if I were to draw the ray in there, let me do that here, and then I'll turn this off so you can see what I'm drawing. So you see that the incident ray comes in like this. Here's our boundary. So that is what the incident ray is doing. And then the reflected ray just bounces right off, right? That, right? It bounces right off and generates some periodic waves there. And they're just bouncing right back off. So the reflected ray and the incident ray are basically 180 degrees to each other. Right? Comes in and goes out the exact opposite way when they are arriving perfectly parallel to the boundary. But now what I'm going to do is I'm going to actually put the boundary at an angle. So instead of it being horizontal like that, I'm going to put the boundary at an angle. So let's say there. Now when the incident ray hits the boundary, you all see the direction it's traveling? Right? It kind of goes down this way now, right? So you watch the incident ray and then the reflected ray goes down that way. Right? You kind of get like a plaid pattern.
Yeah, it crisscrosses.
Yeah. I mean, it's easier to, I think it's somewhat easier to see if you don't look directly at it, if you just kind of look out of your periphery. Sometimes you can see it a little bit better. Kind of see it. Okay, now let me draw in the incident ray and the reflected ray. So obviously, our incident rays coming in like this. So that is the incident ray. Let me draw the boundary and also here's our boundary. Okay, so there's our boundary and there's our incident ray. And then if we focus now on the reflected rays, they're coming down about like this. So let me draw that in. About like that is the reflected ray. Pretty much like that. Now, to understand the behavior that we want to look at, we need to draw a normal line in. Right, so I'm going to draw a normal line in here on the barrier. So there's the normal line. Okay, and that's normal to the barrier. So this makes a right angle to the barrier. Now, what we're going to see is that if we were to measure this angle and this angle, so we're going to call this theta I. Okay, theta I is called the angle of incidence, because it's the angle the incident ray makes with the normal. And we're going to call this angle theta R for angle of reflection. What we see is that if we measure theta I equals theta R. drawn in perpendicular to the barrier, and then what we see is that the angle the incident ray makes with the normal is equal to the angle the reflected ray makes with the normal.
The incident wave and the reflected wave make equal angles with respect to the normal. Again, the incident and reflected waves make equal angles with respect to the normal. If the angle of incidence is 0, then the angle of reflection is 0. If the angle of incidence is 35, then the angle of reflection is 35. If the angle of incidence is 45, then the angle of reflection is 45. If the angle of incidence is 55, then the angle of reflection is 55. Each portion of wave front obeys the law of reflection.
We'll use this ripple tank, which projects an image of waves on the surface of water, to demonstrate the refraction of water waves. When we put a rectangular pane of glass into the tank, the water over the glass is shallower than in the rest of the tank. When the waves cross over into the shallower water, they are refracted to the side.